Hello, we are going to do the problems for the assignment for lesson 111. Okay, problem 1-4. Find f of 3 means to find the output of function f of x for an output of x equals 3. For the function f of x equals 1 over x minus 2, find each of the following values. So part A, find f of 4. This means to find the output of the function when x is equal to 4. So what you're going to do is f of 4, I replace the x with a 4, so in the rule, we're going to replace the x with a 4. So the x was right here, now it's a 4. Then I simplify, we get 1 over 2, 4 minus 2 is 2. And so the answer is 1 over 2. Okay, part B. Now it wants me to find x when the function f of x equals 1. This means find the input that gives an output of 1. So we're going to let f of x in the rule be 1. So the rule starts out with f of x, we're going to put 1, and that's going to equal 1 over x minus 2. So we could plug stuff in, we could kind of guess and check, but I want to show you how to do this algebraically. So what you do is, because we have a fraction and we have the denominator of that fraction is where the input I want, or the value of the x I'm solving for is, you take the entire equation and we multiply that by the denominator. So I get 1 times x minus 2 is just x minus 2. That should equal, well, x minus 2 cancels with the x minus 2. That's why we multiply by the denominator, leaving me with a 1. Then to solve this, we're going to add 2 to the other side. So we get x equals 2 plus 1 is 3. And so I get an answer of 3. Okay, problem 1-5. Angelica is working with function machines. She has the two machines, g of x equals the square root of x minus 5, and h of x equals x squared minus 6. She wants to put them in order so that the output of the first machine becomes the input of the second. She wants to use the beginning input of 6. So this is a lot like problem 1-1. So if you need to go back and look at what we did in, sorry, not 1-1. Problem 1-2, so let's erase all that. So in class we did problem 1-2, which had 4 functions, so this problem is very similar. And so I want to know, in what order must she put the machines to get a final output of 5? Well, if you look at what I have here, if I put a 5 into here right away, I'll get a 0. So that's probably going to be second. So we're going to probably start with h of x first. And then we're going to probably end up with g of x. So let's try that. So let's take h of 5. So h of 6 is what I'm starting with, sorry. H of 6 is going to be 6 squared minus 6. Well, 6 squared is 36, minus 6 is 30. So now let's take 30 and let that be the input for g. So I'm going to take g of 30. So it's going to be the square root of x is 30 minus 5. Well, 30 minus 5 is 25, and we know the square root of 25 is 5. So the order I need to put them in is H, then G. Okay, part B. Is it possible for her to get a final output of -5? If so, show us you can do that. If not, explain why not. So we just saw in the previous part that H then G gives me a positive output of 5. So now I want to get a negative output. So we know we can't go H then G, so let's reverse the order and let's try that out. So let's try G of x first and then H of x. Because if that doesn't work, and I've already tried the other way in the previous part, then it's not possible. So let's start with g of 6. So that gives me the square root of 6 minus 5. So 6 minus 5 is 1. The square root of 1 is 1. Now let's let h input be 1. So I get 1 squared minus 6. So 1 squared is 1. 1 minus 6 is negative 5. That's what I want. And so that is the order I should put those in to get that output. Okay, we're going to skip 5, 1, 6 and go right to 1, 7. So in this course, you will learn shortcuts that allow you to sketch many different types of graphs quickly and accurately. However, when directions ask you to graph an equation or to draw a graph, this means it is not just a sketch you should do quickly. So anytime you graph, you should do 4 things. Always use graph paper if you're not provided a coordinate plane. You should always scale your axes appropriately if your axes aren't scaled. You should already label key points. You should always do that. We'll talk about what that is briefly here in future lessons. And we will plot points accurately. So on separate sets of axes, so in your homework it says using graph paper, graph each of the following equations. If you do not remember any shortcuts for graphing, you can always make an XY table. Okay, so the first one is y equals negative 2x plus 7. So remember, this is a slope-intercept form. So from Algebra 1 in geometry last year, we should remember this form. So let's quickly go over. M is the slope, which is also interpreted as the change in the y over the change in the x. And b is the y-intercept. So to graph these, you do 2 things. So the first thing is you plot the y-intercept. So the y-intercept in this case is 7. So on the y-axis, we're going to plot a point at 7. Okay? So plot that first. And then we apply the slope from y-intercept to plot, and I'm going to go at least 3 other points. Now this has a whole number of slopes. So when I think of whole numbers for slopes, we always want to put them as fractions. So a negative 2 is going to be negative 2 over 1. So when I have a negative slope, I can either make the top number negative or the bottom number. And so remember, when I talk about slopes, the top number tells me how far up or down to go, and the bottom number tells me how far left or right to go. Positive up, negative down. Positive left, negative left, positive right. So I'm going to start off with negative 2, 1. So I'm going to go down 2, right 1. So down 2, right 1, plot a point. Down 2, right 1, plot a point. Down 2, right 1. Down 2, right 1. Do that many times as I want, or I can go positive 2 over negative 1. So up 2 over 1. Now you should use a ruler when graphing a line on your homework, but for mine, there you go, that's what it looks like. Okay, always use a ruler, boys and girls. Okay, next one. Y equals 3/4 x plus 1. So again, I'm going to plot a point at 1. Now, when I have a slope of 3/4, that either means go positive 3, positive 4, or I can make them both negative and go down 3, left 4. So I'm going to start by going positive. So I start with 1, so go up 3, 1, 2, 3 over 4. Plot that point there. Up 3 over 4. I tend to go as far as I can, and then now I'm going to go down. Down 3, left 4. Okay? Down 3, left 4. I tend to plot until I can't plot. Now when you graph the lines, you start outside the coordinate plane. Get your line. Okay, it should start and end outside the coordinate plane. Your arrow should always end up outside the coordinate plane. So there's the graph of that function. Okay, now this is in a different one. This is called standard form. Now to graph standard form, I convert it to slope-intercept form. So we're going to solve this for y. So I'm going to first see the y's here. So we're going to isolate the term with the y by moving the x term to the other side. So since the x term is positive, we're going to subtract it to the other side. And so I'm going to get 2y, and that's going to equal. Now, because I want it in slope-intercept form, the x always goes out front. So I subtracted 3x over, so we make it negative 3x plus 6. And then you're going to get rid of the y by dividing by 2. So we divide everything by 2. So these cancel, leaving with y. Negative 3x over 2 is just negative 3 over 2 times x. And 6 over 2 is 3. So there is my graph, my slope-intercept form. Now use the same technique to graph it. Point at 3. Now 3 is negative, so I'm going to go either down 3 over 2. Whoops. Down 3 over 2. Or I can go let the 2 be negative and 3 be positive. Up 3, left 2. Up 3, left 2. Okay, then I connect the dots. Whoops. I hit the wrong button there. Go through my picture. There is my graph. Okay, set 17D. This one's a little different because it has this x squared, so that's not a line. So this might be easier to make a table as suggested. So whenever I graph new interesting things, I make a t-chart and I always use the same 5 x values, negative 2, negative 1, 0, 1, and 2. So I like to start there. So remember, we're going to take each of these numbers, plug them in individually into my x squared function rule. Now, remember, anytime you square a number, the result is always positive. So when I put negative 2 and I square it, or times negative 2 by itself, I get positive 4. When I take negative 1 and square it, I get positive 1. 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I plot those points. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Now I have some space, so I'm going to actually see if I can plot more points. So let's try 3 here. Keep going. 3 times 3, or 3 squared, is 9. Well, I see 9 is on the graph for y, and 3 is, so I can plot it. Now, one thing I want us to notice is that in this graph, the opposite input, so negative 2 and 2, negative 1 and 1, they have the same result. So 3 is 9, then its opposite should also be 9. So the opposite of 3 is negative 3. Okay, so this forms a graph we should know of. So again, no matter what, I always start outside the coordinate plane. I'm going to connect the dots. I always curve when the graph moves. I don't stop and start. And I should always end up with my arrows outside of the coordinate plane. Okay. 1-8. The graph for part D, the one we just got done graphing, of problem 7-1-7 is different from the other 3 graphs. So explain how the graph is different from the other 3. Well, the graph does not form a line. So graphs that do not form a line, we call them non-linear graphs. So the graph is non-linear. What in the equation of part D makes its graph different? Well, it had that weird thing in the power, so we call that the exponent. The exponent. None of the other equations had an exponent with x. This one did. So it changed the way the graph looked. In part C, what is the graph of part D called? So we call it a parabola. That should be a thing we've remembered from Algebra 1, a parabola. Okay, the last problem. We're going to write down everything we know about the equation y equals mx plus b. We just got done graphing some equations. You should include what this general equation represents, as well as what each of the different letters represents. Be as thorough as possible. So this here, this equation represents a line. So graphs or equations of that form a line when you graph. So the m is the slope of the line. Okay, the slope. Remember, slope dictates the steepness. So the steepness of that line. B is the y-intercept. So again, the graph should have the point 0, comma b on it. And we have two other letters, xy. So when you take xy and you make them a point, xy is a point that is on the line. So again, x and y, if you plug them in with the specific m and the specific b, not only should those x and y values make the equation true, satisfy the equation, but if you were to graph the function, the point should be something the line passes through. All right, so hopefully this was helpful. Please double check your work, and we will see you in tomorrow's core problems video.